Gas exchange is merely can be described as a delivery of oxygen from the lungs to the bloodstream. So moving oxygen from the lungs to the bloodstream and elimination of carbon dioxide from the bloodstream to the lungs. So it's like I don't know if I can see the opposite. So gas exchange is a passive process that depends on a simple diffusion of gases across the alveolar capillary membrane. Factors affecting gas diffusion, which are alveolar capillary membrane, functional surface area, physical properties of gases, solubility, molecular weight, hemoglobin, ventilation, and partial pressure gradient. Firstly, we will begin with the alveolar capillary membrane. In case, in case of an edema or lung fibrosis, these cases will decrease the gas diffusion between the blood and alveoli because of the massive thickening of the alveolar capillary membrane. Here in the figure, it shows how the lungs alveolar capillary membrane is super thickened, so it restricts the diffusion of the like restrict the diffusion between the blood and the alveoli, thus it decreases the gas exchange. The second factor, which is the functional surface area, as the surface area of the alveolar capillary membrane increases, then the gas exchange will be increased also. So this is their relationship is direct proportional, and the surface area increases during exercise, lifting some weights, doing some physical activities, running, things like that. The third factor, which is physical properties of gases like solubility and molecular weight, and each of them has a specific effect. Firstly, solubility. The more lipid soluble the gas is, the faster it will dissolve through the alveolar capillary membrane, meaning that it is direct proportional. The molecular weight, the higher the molecular weight the gas is, the slower it will diffuse through alveolar capillary membrane. So their relationship is inversely proportional, meaning that the heavier the gas is, the slower it will diffuse through alveolar capillary membrane. And we have hemoglobin. Actually, hemoglobin is very important to maintain the concentration gradient of oxygen from the alveoli to capillaries, meaning that hemoglobin form a reversible binding with the oxygen, which is oxyhemoglobin. This is the combination's name. Because why such a combination is important? Because transit time of blood to across alveoli is 0.767, and oxygen reaches equilibrium in 0.3 seconds. So that explains the importance of hemoglobin and how it affects the why it is a factor affecting the gas exchange. Here, this figure shows how the gas exchange occur, in which the oxygen moves in and the carbon dioxide moves out.